In this Technological Innovations in Forestry module, we will learn remote sensing and monitoring tools. In the past, primitive forestry practices often involved unsustainable methods such as clear-cutting, which could lead to deforestation and ecosystem degradation. Lack of advanced technology made it challenging to monitor and manage forests effectively. This shift has promoted conservation, biodiversity, and overall forest health, making contemporary forestry more environmentally friendly and sustainable. Traditional forestry refers to the historical and conventional practices of managing and utilizing forest resources for various purposes. In traditional forestry, harvesting, timber extraction for construction, fuel, and other uses was a primary focus. Selective logging and clear-cutting were common methods. Management: forests were often managed for short-term economic gains, leading to practices that may not have been sustainable in the long run. Biodiversity: traditional forestry often didn't prioritize biodiversity conservation, and monoculture plantations were common. Awareness: environmental awareness and considerations for the ecological impact of forestry practices were generally limited. Technology: traditional forestry relied on manual labor and basic tools for activities like logging, planting, and monitoring. Modern forestry practices have evolved to incorporate sustainability, biodiversity conservation, and advanced technologies for more effective and environmentally friendly forest management. We talked about traditional forestry and what technology has brought. Now, let's find out which technological tools exist. Forest management and forestry have undergone significant transformation and improvement with technological innovations. Here are some technological innovations observed in forestry. UAVs. UAVs are used to observe areas in forests, monitor tree conditions, and detect fires. They are also used for mapping forest areas and obtaining topographic information. LiDAR technology. LiDAR technology enables detailed mapping of forest areas. It is used to obtain important data such as tree heights, densities, and soil profiles. Satellite imaging and GIS. Satellite imaging and geographic information systems provide essential tools for forest management, including mapping, spatial analysis, and resource management. These technologies are used to monitor the status of forest areas, analyze changes, and optimize management strategies. Fire detection and monitoring systems. Thermal cameras and sensors are used to detect and monitor fires. Additionally, air and ground-based systems have been developed for rapid intervention during fires. Smart wood processing and monitoring. RFID and NFC technologies are used to track wood cutting and transportation processes. This can help the forestry industry manage resources more efficiently. Biotechnology and genetic engineering. Biotechnology and genetic engineering techniques are used to alter the genetic characteristics of forest trees, producing more resilient and fast-growing species. Data analytics and machine learning. Large datasets from forests can be processed using data analytics and machine learning to make better decisions in forestry management. These technologies are used to monitor forest health, assess fire risk, and track biodiversity. These technological innovations have the potential to make the forestry sector more sustainable, effective, and environmentally sensitive. Using remote sensing data in forestry. Challenges and opportunities. The transition to operational use of new remote sensing data and technologies in forest inventory programs poses a significant challenge for many countries. Existing programs often rely on established technologies like aerial images, while newer technologies such as airborne laser scanning gain importance in certain regions globally. The timing and approach to incorporating these advancements into existing programs vary based on budgets, staff, infrastructure, and user base. Now, let's discuss some challenges remote sensing research faces in integrating technologies into forest programs. National forest inventories, improving estimates of forest attributes at a national level, meeting reporting obligations. Plot level measurements, enhancing efficiency or expanding ground measurements. Management level forest inventories, producing continuous maps with important forest attribute estimates for informed decisions. Temporally continuous forest monitoring, providing detailed information about forest states and changes over time. Here are the recommendations we can offer for these challenges. Start now, don't wait for the technology to fully mature. Begin with your business needs. Combine technologies to address specific problems. Make the best use of existing data. Consider the full set of enablers. In this Technological Innovations in Forestry module, we learned what innovations we have encountered in traditional forestry, what remote sensing and monitoring tools are, and the difficulties and advantages of these innovations. Thank you for accompanying us. See you in our next information video.